Everybody seems to like ChatGPT physics videos, so I got to make another one, right? I got to do what people want. So here I am doing what you want. I'm here to serve. Okay, so I want to do another problem. Let's just jump to the problem. I'm going to switch over here. Okay, so I like to find problems from this site that's called something that rhymes with flag. And here's one I just looked through, and I want one that's like, not just dumb or tedious. And this is the one that looks like someone made on their own, so it's not from a textbook. So it says a pendulum is raised to a height of 4 meters above the ground. The string is connected to a bobber. A bobber. The string connected to the bobber is 3 meters. The mass of the bobber is 12 kilograms. That's a pretty big bobber. How fast is the bobber going 2 meters off the ground? So I assume they release it from rest up here, and it swings down and goes down here. So it's not too terribly difficult of a problem if you use work energy, but let's see what ChatGPT does. Now, ChatGPT is kind of slow, so I preemptively put the answers in here. I didn't really look at it, but let's see, here it is. So I said, and this is something that is fun, right? Because I said, can you solve, just for fun, can you solve this physics problem using the voice of Data from Star Trek? Just for fun. And so then I gave a link to the problem, and it obviously can read the problem. And you'll notice over here, look at the problem. Okay, it has this words up here, but then it's got the picture. So I don't know if it's reading the picture or what. Show transcribed text image. I just gave it the link. Okay, that's pretty good. Okay, I'm impressed. I'm impressed right away. Okay, going back over here to forces. Okay, so it says, Captain, I have solved. No, that's not Data. Captain, I have solved the given physics problem. To calculate the velocity of the bobber of the pendulum at the lowest point, we can use conservation of energy. Good job, Data. And I do like using in the voice of C-3PO or Data or some other fictional robot, because I should try R2-D2. As we know, the initial potential energy is equal to the final kinetic energy. I don't like that. I mean, it doesn't have to be wrong. It depends on where you define your potential at. The initial potential energy of the pendulum is mgh, okay, where the mass of the bobber, where m is mass of the bobber, g is acceleration due to gravity, gravitational field, and h is the height from which the pendulum is raised, which is 4 meters. Okay, that's not going to be right if they do it the way I think. The final kinetic energy is 1/2 mv squared, where v is the velocity. Therefore, we can set up the equation. So this is wrong. Let me do the problem, and then I'm going to tell it it's wrong. Okay. Okay, so we're over here. Let me draw the picture, going back to this. So here we have the bobber. And this is 3 meters long, and it swings down here. And it said, let's see, it said that, I'm looking at the picture, 2 meters. So this is the ground, and so this is 4 meters, and this is 2 meters. And we actually don't know, it doesn't explicitly say that it's not the lowest point, but who knows, right? Because we don't know how far the ground is from the lowest point. Is this the lowest point? I don't know. It doesn't really matter though, right? So let's say I'm going to define my system as the bobber. I'm going to use the bobber. The bobber plus the Earth. And if I include the bobber and the Earth in my system, then I can have two kinds of energy. I can have kinetic energy, 1/2 mv squared, and I can have gravitational potential. I'm going to say mgy. Okay, and then I'm going to put y equals 0 down here. You have to pick a location where the potential is equal to 0. And you could put it up here. It'll work either way. The only problem is that up here, there's some unknown distance. It'd still work out because that unknown distance is in both of these. It really depends on the change in distance right here. So with that, I can say work is the change in energy. And now what forces do work on the system? Well, not gravity because it's part of the system. I do have a tension force right here that's pulling on the bob, but it doesn't do any work because it's always moving perpendicular to the tension. And so the angle between the tension and the displacement is 90 degrees, zero work. So I have zero work. I'm going to put this as change in kinetic plus change in potential. So 0 equals K2 minus K1 plus U2 minus U1. And let's call this 1, and let's call that 2. Okay, now if I release it from rest, then K1 is equal to 0. And they were asking how fast. How fast? So I'm going to write this out as 0 equals 1/2 m v2 squared plus minus 0 plus u2 is going to be mg, I'll call this just y2, that's y2, minus mgy1. And I want to solve for v2. So the mass cancels, and I get v2 squared is going to be, I'm going to add these to the other side, is going to be equal to 2gy1 minus gy2. And then I take the square root. And I'll put in our numbers. So I get the square root of 2 times, I'm going to factor out the g, times 9.8 times y1, which is 4, minus y2, which is 2. I'm going to put it in my calculator, which I don't like calculators, but you know, here we are. Put that right there. So I'm going to get the square root of 2 times 9.8 times, well, I'm just going to put this as 2. 4 minus 2 is 2. And I get 6.26 meters per second. Okay, let's see what ChatGPT did with this for us on a box. They got 7.68. Let's see. I think this is wrong. Oops, I didn't switch over here. I'm sorry. I think this... No. Okay. I think this is wrong. You assumed the final height of the bobber was 0. Of course, this is the thing. Would data apologize like that? The pendulum is 3 meters. It's not 3. The lowest, see, this is one of the classic things, like there's the number 3, I have to use it in there. There's the number 12, I have to use it in there. Okay. MGH equals MG final 3. I think the final position is 2 meters, not 3. I think the final position is 2 meters, not 3. What would data say? I apologize for the error in my previous. Okay. So again, we see that ChatGPT is not that great at physics. It is good, pretty good at impersonating people, and I do respect that. Let's see if it gets it right this time. Okay. Oh, wait. 2GH minus 2GH, and they got 5.6. What the heck? Square root, did I put that in wrong? Square root, I'm just gonna just put this in Google. Just for fun. Just put that. You see? That's wrong. That's just so weird. 6.2. I mean, I even left the units in there. That's actually pretty impressive for Google. I'll tell you right now. That you can just put the units in there and everything, and it did it. Okay. So how about this? Can I link to this? How do I link to this answer? Tools. I want to link to the right. Oh, that's kind of cool. I'll just do this. I put that calculation into Google and it gave me this. As you have calculated using a calculator or Google, it's important to keep in mind this calculation is small. Yeah, but yours is way off, dude. Way off. But you are way off. Okay, you apologize for everything. Can you please stop apologizing for everything? Okay. I do like this new stop generating, but I want to let it go. No, it's just, that's fine. Okay, I think we're done. I'm done with you. But that's fine. I still enjoy this. And this is, still would be a great thing for students to play with to see what did ChatGPT do wrong. That's kind of fun, right? So there's that. Okay. So that's the end. I'll do another. I have a couple more problems lined up with ChatGPT that I already put in. So I'll make some more ChatGPT videos. Talk to you later.